Welcome! If you've just started learning Python, you've probably already worked with variables, storing a name, a number, maybe a score. But what happens when you need to store 100 names? Or keep track of students and their grades? That's exactly where data structures come in. Think of a data structure as a container. Just like you'd use a drawer for socks and a shelf for books, different data structures are designed to hold different kinds of data in different ways. In this tutorial, we'll cover Python's 4 most useful built-in data structures: lists, tuples, sets, and dictionaries. We'll also touch on queues, stacks, and trees. Let's dive in. Lists are probably the first data structure you'll ever use in Python. A list holds items in order, and you can add, remove, or change anything inside it. Watch as we create a list of movie titles using square brackets. Notice how Python automatically assigns each item an index starting from 0. So the first movie, Inception, sits at index 0. This 0-based indexing trips up almost every beginner, so keep it in mind. Now look at the .append method. When we call movies.append with tenet, a new box springs in at the end of our list. Then .removed finds the matrix by value and takes it out. Watch the visualization update in real time. See how the output panel shows our final list with 3 movies. Use a list when the order of items matters, when you need to add or remove items over time, and when duplicate values are okay. A real-world example is a shopping cart in an online store. Now, let's talk about tuples. A tuple looks just like a list, but it uses parentheses instead of square brackets. And once it's created, you cannot change it. This is called being immutable. Watch as we create a tuple with the GPS coordinates of the Eiffel Tower. We can still access individual items by index, just like a list. But here's the key difference. If you try to modify a tuple, Python will throw a type error, and that's actually a feature. It protects your data from accidental changes. Now look at this tuple of days of the week. These never change. So a tuple is the perfect choice. Use a tuple when your data is fixed and shouldn't be modified, when you want slightly better performance than a list, or when you're representing something that's naturally a pair or group. Sets are collections that hate duplicates. A set is unordered, which means the items don't have a fixed position and every item must be unique. Watch what happens here. We create a set with Alice, Bob, Charlie, and Alice again, but when we print it, the duplicate Alice disappears. Python automatically removes it. That's the power of sets. Now, here's where sets get really cool. You can do math-like operations on them. Look at these 2 sets, one for Python developers and one for JavaScript developers. When we use the ampersand operator, we get the intersection. Who knows both languages? Charlie. The Venn diagram on screen shows exactly how this works. The overlapping area is the intersection. Use a set when you want to eliminate duplicates automatically, when you need to check if an item exists quickly, or when you want to compare 2 groups of data. Dictionaries store data as key-value pairs. Instead of accessing data by position, like in a list, you access it by a meaningful label called a key. Watch as we create a dictionary for a student with 3 keys: name, age, and grade. When we access student bracket name, we get Jordan. When we access student bracket grade, we get A. Now look at how we add a new key. School equals MIT. A new key-value pair springs into the visualization, and when we update grade to A+, the old value is replaced. Here's a pro tip. Use the .get method for safe lookups. If you try to access a key that doesn't exist with brackets, Python throws a key error. But .get lets you provide a default value. So, student.getMajor with a default of not declared returns, not declared, instead of crashing. Use a dictionary when you want to label your data meaningfully, when you need fast lookups by a specific identifier, or when you're storing related fields about one thing. Now, let's look at two patterns you can build using lists: stacks and queues. A stack follows LIFO, last in, first out. Think of a pile of plates. The last plate you put on top is the first one you take off. Watch as we push page 1, page 2, and page 3 onto our stack. They stack up from bottom to top. Then, when we call .pop, page 3 comes off first, because it's on top. This is exactly how a browser back button works. Now, a queue follows FIFO, first in, first out, like a line at a coffee shop. The first person in line gets served first. We use the DQ class from Python's collections module. Alice joins the line, then Bob. When we call .publipt, Alice gets served first because she was first in line. Use a stack when you need undo or back functionality. Use a queue when you need to process items in the order they arrive. Trees are more advanced structures where data is organized hierarchically, like a family tree or a folder system on your computer. Let's look at a binary search tree. In a BST, smaller values go to the left and larger values go to the right. Watch as we define our node class with a value, a left child, and a right child. Then we define the insert function. If the new value is less than the current node's value, we go left. Otherwise, we go right. Now, watch the tree build itself. First, we insert 50. That becomes our root node at the top. Then, 30 goes to the left because it's smaller than 50. Then, 70 goes to the right because it's larger. Finally, 20 goes to the left of 30. See how the tree organizes itself? This structure lets us search for values incredibly fast. In logarithmic time, trees are used in file explorers, database indexing, and decision-making algorithms. Here's a quick comparison table to help you choose the right data structure. Lists are ordered, mutable, and allow duplicates. They're your general-purpose collection. Tuples are ordered but immutable, so they're perfect for fixed, constant data. Sets are unordered, mutable, and don't allow duplicates, ideal for unique items and fast membership checks. Dictionaries are ordered in Python 3.7 and later mutable, and use unique keys for labeled data and fast lookups. Each structure has its strengths. Pick the one that matches what you need: order, mutability, uniqueness, or labeled access. Here's your cheat sheet. Need an ordered list you can edit? Use a list. Have data that should never change? Use a tuple. Want to store only unique items? Use a set. Need to label your data with keys? Use a dictionary. Processing items in order? Use a DQ. Need undo or back functionality? Use a list with .pop. Organizing hierarchical data? Use a tree. Data structures are the backbone of every program you'll ever write. The more comfortable you get with them, the cleaner and faster your code will be. Happy coding! You've mastered Python's core data structures. We covered lists, tuples, sets, dictionary stacks, queues, and trees. Each one has its place in your programming toolkit. If you found this helpful, give it a like and subscribe for more Python tutorials. More content is coming soon. Happy coding!